Hello everyone. Today we will solve one numerical on the basis of designing of a belt system. So we have been given a problem statement in which the belt system is supposed to transmit a power of 15 kilowatt. The center to center distance between the two pulleys, this one is a smaller pulley while this one is a larger pulley or bigger pulley, and this is the center to center distance 2d between the bigger pulley and the smaller pulley. So the center to center distance between the pulleys is twice the diameter of the bigger pulley. Belt should operate approximately at a velocity of 20 meters per second, and stresses in the belt should not exceed 2.25 Newton per mm square or 2.25 megapascal. Density of the leather material is 0.95 gram per cc. We will come to this unit later on during the solution. And the coefficient of friction is 0.35. The thickness of the belt is given as 5 mm. Now, on the basis of this data, we need to find out the pulley diameters as well as length and width of the belt, and finally the tensions in the belt. So we will proceed towards the solution. We will make use of this diagram as well. There is some data which is given in the form of diagram. So as per our usual practice, we will first take down the given data. So the given data, like I have said so many times before, that it is not carrying any marks in the examination or solution, but it helps you to properly organize your data so that you can pick the quantities whenever they are necessary during the solution. So the power transmission, it is equal to 15 kilowatt. After that, the center to center distance, capital C, it is 2 times the diameter of the larger pulley, capital D. Then belt should operate at a velocity of 20 meters per second. Then the stresses in the belt, they should not exceed sigma 2.25 megapascal, and the density of the belt material, it is 0.95 gram per cc. Then coefficient of friction, which is F, it is 0.35. Now we can proceed with the solution. So we will need to sort out the things with the help of velocity, because indirectly actually some given thing is given in the diagram. So speed of rotation of the smaller pulley, so that is small n, this is 1440 rpm, while speed of rotation of the larger pulley, which is capital N, it is 480 rpm. So we can simply use the relationship between the rotational speed, diameter, and the linear velocity to determine the value of diameter. So the first thing that we know is that velocity v is given as pi dn upon 60. So we can substitute the values. Velocity v, I will just put it here. So velocity v is 20 meters per second. It is equal to pi, and the small d is the unknown parameter. Small n is, by the way, known to us. It is 1440 rpm divided by 60. But remember, the velocity is given in meter per second, this velocity. While if we want the diameter in mm, because the stress distribution is in Newton per mm square, at some point it might be necessary. So we have to multiply this 60 by 10 raised to 3, so that resulting diameter will be in mm. So 60 into 10 raised to 3. Now I will suggest you solve this using your calculator. So that will tell us that the value of small diameter d is approximately 265.26 mm. We can round it off to 270 mm. So that is our first answer, the diameter of the smaller pulley. That is what we have calculated. Now after that, we know the relationship between the diameter of the pulley and their speed. The relationship is that they are inversely proportional. So if diameter is more, then speed of rotation will be less. So when you represent this inversely proportional, or somewhere I will write it, so it is actually inversely proportional to the diameter, so which means that nd is constant. So, or in simple sense we can write that the product is constant, so nd is equal to nd. So same thing I'm going to write here, capital N capital D, that product it is equal to small n small d proportionately. So that gives us capital N in this case is 480 rpm, capital D is not known to us, small n is 1440 rpm, small d just we have calculated, we can take it, so that is 270 rpm. On the basis of this we can say that capital D, that is diameter of the bigger pulley, it will be equal to 810 mm. So now we have diameters of both the pulleys, so we can say that in the problem statement, the first thing, the diameter of pulley or both the pulleys has been calculated. Now we will proceed for the length and width of the belt. So we know the formula for length of the belt. The length of the belt, capital L, it is equal to 2c plus pi times d plus d, pi times capital D plus small d, capital D plus small d divided by 2 plus capital D minus small d bracket square divided by 4c. Now in this equation there are two terms, that is c. So already it was specified in the problem statement itself that capital C was nothing but 2 times capital D. So we can immediately evaluate that. So this is equal to 2 multiplied by 810. So that gives us 1620 mm. This is the value of capital C. We can back substitute the value in the expression of capital L and we can evaluate the capital L. So that gives us 2 into 1620 plus pi into capital D that we have is 810, small d that we have is 270 divided by 2 plus capital D is 810, small d is 270, entire bracket squared divided by 4 multiplied by capital C is 1620, so that is 1620. So ultimately what we get is the value of length of the belt, which is 4981.46. Sorry, one second. Yes, so that is 4981.46. You please calculate this using your calci as well, because this is a mathematical treatment, so it has to be done individually with hands-on approach. So we have this capital L. After that we have seen that the problem statement itself tells that the velocity is approximately 20 meter per second, but then in this stage here we have adjusted the diameter or rounded it off. So because of that we will have to calculate the corrected velocity. We will need to check whether it has changed significantly or not. So velocity v is again pi dn upon, like I said, 60 into 10 raised to 3. Remember, you have to divide by 10 raised to 3 when you are using diameter in mm, so that your final velocity comes out in meter per second. So ultimately now refined velocity or corrected velocity, pi multiplied by 270, rpm is 1440 divided by 60 into 10 raised to 3. If you calculate this velocity, you will get the answer as 20.36 meter per second. So yes, we are very close to the design value of velocity, which is 20 meter per second. So this value of small d is acceptable. On the basis of this, now we can calculate the value of angle of contact or angle of wrap of the belt on the smaller pulley, which is alpha s, which is given as 180 minus 2 times sine inverse of capital D minus small d upon 2c. So we have this entity with us. So this is equal to 180 minus 2 times sine inverse of capital D is known to us, which is 810, small d 270, divided by 2 times capital C, which is 1620. So now on the basis of this we can calculate, put it in your calculator. So alpha S, it comes out to be 160.8 degrees, and for the purpose of utilization of this entity in the mathematical equation we have to convert it into radian. So this will be equal to 160.8 into pi by 180. So alpha S is actually 2.81 radian. So we will be using this second value of alpha S during the further calculation. So the next thing that we need is the calculation for the purpose of width of the belt, and that is not a simple quantity to be obtained. For that purpose we have to make use of several quantities. First of all, it has been given that density of the this leather is 0.95 gram per cubic centimeter. So we will need to determine its mass. On the basis of that mass, let me show you the flow, what we are thinking. So see, we have been given rho. On the basis of that we can calculate the mass. On the basis of mass we can calculate the product mv square, and we have some relation called as p1 minus mv square upon p2 minus mv square, and it is equal to, because this is a simple plain belt, they have not specified that it is a V belt, so this is equal to F alpha. So now we again do not know what is P1 and what is P2. Then we know one more relationship about P1 and P2, that if we calculate P1 minus P2 into V, the velocity V, and divide it by 1000, we get the power transmission capacity of the belt. So to determine again P1 and P2, we can utilize these two equations, but there is one concern, that in this case again mass is not known to us. So we can use one more relation, that the maximum stress in the belt has been provided to us. So it means sigma has been provided. So maximum stress, permissible stress sigma, is nothing but maximum load which can be taken by the belt, which is equal to P1 divided by cross-sectional area. So from this we can directly calculate whether there is any relationship between P1 and the width B, because P1 will be there while area of the belt, it will be equal to whatever is the thickness. I think it is 5 mm specified. So whatever is the thickness multiplied by width of the belt. So using these multiple relations we will be able to determine the relationship or equation which will lead us up to the value of width. So we will begin one by one. So like I said, first of all, on the basis of density we will calculate the mass of belt, and for this we will use our basic understanding that the density is mass per unit volume. So it means that if you want mass, so it is equal to density multiplied by volume. So the mass of the belt M, it is equal to density multiplied by volume. Now what exactly is volume? So volume is nothing but whatever is the cross-sectional area multiplied by the length. So we can simply write the length multiplied by width of the belt multiplied by the thickness of the belt. Fine. So here also we get the expression of V. The term of V is there. So density is 0.95. Remember, this is in gram per cubic centimeter. So it means all the other parameters also, they have to be in the unit of this gram per cubic centimeter, or either centimeter or simply meter. Now the length of the belt, which has been specified in the problem statement itself. No, the length of the belt has not been given in the problem statement, but then we can calculate the volume for unit or for unit length of the belt, that is 1 meter length of the belt. So if we specify 1 meter length of belt, so this is equal to 100 centimeter, which is synonymous to the unit of this row quantity, the density. So the length of the belt, which is 100 centimeter. Width of the belt, it is not known to us. Let us say it is B mm. So we have to divide it by 10 to get it in B centimeter. This is already 100 centimeter. The thickness is 5 centimeter. So sorry, thickness is 5 mm. So 5 by 10 centimeter. Now this gives us a very systematic approach or uniform system of units. So this thing is now known to us. So actually this is 100 centimeter per meter. So overall the expression of this entity is gram per meter. That will be the mass, the total mass from this expression. So because this is cubic centimeter in the sense this is centimeter cube. So this cc, so 1 centimeter, and 1 centimeter, they will be absorbed. So centimeter cube will be absorbed. So what will remain with us is gram from here and per meter from here. So ultimately it will give us this entire equation, grams per meter. That will be the mass equation. So let us now multiply all the quantities. So m will be equal to this quantity, but then this is still in gram. We can convert it into kg. So that will be 0.95 multiplied by 100 multiplied by, actually we can simply nullify this 100 and this product of 10 and 10, your choice. So that will be b by 10 into 5 by 10 multiplied by, just a second, yes, multiplied by 10 raised to minus 3. Now this will be in kg per meter. This is the unit mass of that belt. So when we take this entire product, what we get is simply 4.75 into 10 raised to minus 3 times b kg per meter. Actually this is the expression of mass. So remember, we have still not obtained mass completely or width completely. So that is why I showed you initially this flow of equations, that because of that only one unknown, these multiple equations will be needed to be handled. Okay, so m is there. Now after that we know that the product mv square, like I just said previously, so m is 4.75 into 10 raised to minus 3 into b, and the velocity square, so velocity we have calculated now 20.36 squared. So mv square is equal to 1.97 b. This is now available with us. Also we can reduce the terms. We can calculate the term f alpha, exponential of f alpha. So it means that exponential of f is 0.35, alpha s that we have calculated as 2.81 radian. So that will give us value as 2.67. So this term is also available to us. So now we will proceed towards our first expression. The first expression is the relationship between P1 and P2, P1 minus mv square upon P2 minus mv square. So this is equal to e raised to f alpha. So now we can substitute the values. Once we substitute, we get P1 minus 1.97b divided by, because this value is from here, mv square has been borrowed from here, so P2 minus 1.97b, this is equal to e raised to f alpha we have just calculated, so that is equal to 2.67. Now we can take this entire term on the other side. We can multiply this term by 2.67, and on the left hand side we will be having only P1 minus 1.97b. So this is equal to actually 2.67 into P2 minus 1.97 into 2.67b. Fine. When we solve this with the help of calculator, the expression that we get is, now we can take all the terms on the on one side. So Correspondingly, we get P1 minus 2.67 P2 plus. Now remember, when this entire term, it will come on the left hand side, it will become positive and it will subtract this 1.97b term. So that gives you plus 3.29b. This is equal to 0. So we will mark it as our second important equation because it gives us the relationship between P1, P2 and B. Now we will move on to the next equation, which will tell us something about P1. As we know that P1 is the maximum load that can be carried, so maximum tension that can be carried in the belt. So we can say that maximum stress is equal to maximum tension, which is P1 divided by cross-sectional area. The stress has been specified as 2.25 Newton per mm square. It is equal to P1 and A will be the cross-sectional area. Remember, A is nothing but cross-sectional area of belt. So A will be equal to whatever is the thickness multiplied by width. So it means that if I want P1, so P1 will be equal to the product of 2.25 and 5 multiplied by B. So that will be 11.25 B Newton. This will be the P1. Again, one more relationship between P1 and B that we have. Now, what we can do, because we have so many unknowns, that's why we need so many equations. Number of equations should be equal to number of unknowns. We can substitute this value in here, but still we do not have anything about P2. So we need to find it out. So P1 minus P2 into V divided by 1000 is nothing but the power transmission capacity of that belt. So already this kW is known to us. We can multiply this 1000 there and we can divide by V. So that gives us P1 minus P2. So kW, the power transmission capacity, is 15 kilowatt. Multiply it by 1000 divided by velocity 20.36. So ultimately we arrive at this conclusion that P1 minus P2 will be equal to 736.74 Newton. So now you have one more relationship between P1 and P2, or in simple language you can write that P1 is equal to P2 plus 736.74. So now you can substitute the equation. You can substitute this equation, both of them, or ultimately the P1 is P2 plus 736.4, and then you can substitute in this main equation. Once you substitute that by simultaneous solution, you arrive at the final value. Ultimately you will get what exactly is B. B will be equal to, that is width, 127.02 mm, or when we round it up it will become 130 mm. On the basis of this B, immediately we can calculate P1, because P1 is equal to 11.25 B. So it is equal to 1428.98 Newton. Then we have the relationship between P1 and P2. So it implies that on the basis of this we can immediately calculate P2, which will be equal to 692.26 Newton. So now we have the values of P1, P2, P1 as well as P2 as well as width of the belt. All these entities are known to us. So what else was asked? I will just need to check. So we have length and width of the belt, as well as we have the belt tensions, which are all the unknown entities which are required as the solution of the problem. So I hope this solution was useful. It was based on the simple understanding that first of all we need to determine the diameters, and then we go for the angle of contact alpha s, then we evaluate mass of the belt, then we determine the relationship between P1 and P2. Once we have that, or actually we are determining the relationship between P1, P2 and B, width of the belt. So ultimately we can arrive at our three final answers. So width is 130 mm, and this P1 and P2, they have been solved. So I hope this was useful. We'll see in the next lecture. Thank you.